Okay, so today we are starting with sections 1.3 and 1.4 in our textbook. Can you guys see it okay up there? Yes, okay, good. Enthusiasm is good. Don't be afraid to be enthusiastic. I know how much you all love math, right?
Sure.
Okay, so here's the deal. I actually take notes or do notes in what's called Cornell note format. Has anyone heard of that before?
Yeah.
Okay, so you don't have to do it that way, but it's something that it kind of gives you a study guide right off of the bat. Okay, so the only difference between Cornell notes and other types of notes is you draw a line down the page, like that, okay? And you put any key terms or example problems like the directions on the left-hand side of the line, and then any definitions or solutions on the right-hand side. Kiani?
Are you doing notebook checks this year?
I am not doing notebook checks this year, no. Okay. Now, again, you don't have to do Cornell notes if you don't want to, but it's something that will help you if you want to study for practice tests and that kind of thing. All right, so here we go. We're going to just go through some key terms. So let's start with some properties that we had back in Algebra 1. So actually, the first half of Algebra 2 is a really in-depth Algebra 1 review. Okay, so this is not going to be a lot of new stuff yet. Okay, so the first one is the commutative property. Okay, let me know if you guys can't see anything or if my handwriting is super awful. I need to work on that. Okay, so the commutative property. All the commutative property says is that you can add things in different order or multiply things in different order and it doesn't make a difference, okay? So in other words, 5 plus 1 is the same thing as 1 plus 5. So switching the order around doesn't make a difference. That's all it says. Okay, so if we put it in general terms, A plus B is the same thing as B plus A. Okay? It also works with multiplication. How many people agree that 2 times 7 is the same thing as 7 times 2? That switching the order of multiplying them does not make a difference. That's, again, all this property says. Okay. Next one. Next one is the associative property. And all we're doing today is getting some practice with these. So we start out pretty easy here. Okay, so the associative property. So think about your groups of friends. And you associate with certain people, right? So you have groups of people that you associate with. So that's what the associative property is saying, is different things are being grouped together with parentheses. Okay, and so what this says is that you can move those parentheses around and it doesn't make a difference. So let's say I have 5 plus 1 plus 3. That is the same thing as if I shift the parentheses over 5 plus 1 plus 3. So keep all the numbers in the same place, but move the parentheses around. Okay, so if we were to continue on with this, 1 plus 3 is 4. So 5 plus 4 is 9, 6 plus 3 is 9. Okay, so generally speaking, A plus B plus C equals, if I shift the parentheses around, again, shifting them around doesn't make a difference. That's all it's saying. And it works the same way with multiplication. A times B times C is the same thing as A times B in parentheses times C. Can you guys see it okay? Up there? I will take your silence as a yes. Okay, next one. Identity property. Okay, so the identity property just says that if you add 0, so as far as addition goes, if you add 0 to any number, you're going to end up with the same number. Okay, so everybody, what is 5 plus 0? Seriously,
5.
everybody? Everybody focus for the 5 plus 0 is, okay, you're scaring me, you guys. Okay, 5 plus 0 is 5. Or, again, you can make a more general form of that. Any number, A represents any number, A plus 0, you're going to get the same number. It works the same with multiplication, except not with the number 0, with the number 1. So 5 times 1 gives you 5. So if you multiply any number by 1, you get the number that you started out with, or A times 1 equals A. Let me put some boxes around this so you guys can see the actual properties here. There and there. Okay? All right, let's see. All right, couple more and then we'll do some examples, okay? All right, am I good to move this up? You guys all have numbers 1 and 2? Okay. So, next one, distributive property. Okay, so the distributive property, let's see. If we start out with something being multiplied by another something in parentheses, distributive property means you distribute whatever is outside of the parentheses to everything inside. Okay, so this is the arrows. So A times in parentheses B plus C is the same thing as A times B plus A times C. Okay, so if we look at a more specific example of that, 5 times x plus y, if we distribute that, can somebody tell me what we get when we distribute 5 times 5 into the parentheses? Rebel.
5x plus 5y.
Good. And how did you get that?
I distributed the 5.
Good. 5 times x is 5x. 5 times y is 5. Okay. All right. Same thing with subtraction. You just always have to look at whatever the sign is inside of the parentheses. Okay, so this is AB minus AC. I'm sure you all can see that. You can. All right, how are we doing on questions? Is this a review for everybody? Okay. Am I going too slow? Okay. All right. I think that'll be good for our key terms. Does everybody have this? Can I move on? Can I move the page? All right, let's try moving it up and see what happens. That's a little better. All right, so let's do a couple of examples here. All right. Okay, so let's see. I don't like that example. All right, so here we go. Use the commutative property to write an equivalent expression. Use the commutative, I'm going to abbreviate here, property to write an equivalent expression. Okay. Let's see. So the first one, 9y plus 73x. All right, so let me give you guys a minute to copy that down, and then we'll go through it. So they're not necessarily in the book. Some of them are. Yeah. So it's different from last year. Yes. This, so use it's commutative, what? 9y plus 73x. Uh-huh. Okay, so commutative property, remember that's the one that, if I go back here, commutative property is the one that says you can switch the order of adding or subtracting, or no, not subtracting, adding, and you end up with the same thing. So how many people can look at this and tell me what an equivalent expression would be? Okay, Juliana.
73x plus 9y.
Good, 73x plus 9y. So all we're doing literally is flipping the order around, and that's it. Okay, how about 32a times, so 32a times negative 12b. So it's not asking, make sure you read the directions on all of these. It's not asking you to actually multiply those. It's saying, what is an equivalent expression? Cole?
Is the second term negative 12b?
Yes.
Okay, then you can do negative 12b times 32a.
Perfect. So all you're doing is switching the order. Okay, so here is the awesome thing about Cornell Notes. Doesn't necessarily make a huge difference with the key terms, but again, what you can do is, for those of us who are get really excited about tests, you can want to study a lot. I know that's all of us, right? What we can do is we can fold the paper, and then what you have on the left-hand side is a bunch of practice problems, and then on the right, if you flip it over, there are all the answers. Okay, so that's the whole idea behind Cornell Notes. Okay, so let's keep going here. All right, so let's now move on to the next property. So the next one is the associative property. Use the associative property to write an equivalent expression. How we doing on questions, you guys? So far, so good? Okay. All right, so the first one, we have 9x. I'm going to write this down here so I don't run out of room. 9x plus 8z plus 3y. So 9x plus 8z plus 3y. We want to write an equivalent expression for that. Okay, and if we go back and look, the associative property right here is the one where you move the parentheses around. Okay? So can somebody tell me what an equivalent expression to this, one equivalent expression. Jessica. Perfect. Good. All you're doing is moving the parentheses around. You want to go through another of these with multiplication, or are you guys okay? Yes, question. It says 9x plus, in parentheses, 8z plus 3y. Other questions? Okay. So we do not want another one with the associative property? We're good on this? Okay. All right. Use the commutative and associative properties both to write equivalent expressions. So we're doing lots of combinations of things. Rebel, I can see that you're very excited by this lesson. Chill out, man. Chill out. Just kidding. Okay, use the commutative and associative property to write an equivalent expression. Okay, so there are lots of different options here. There are no really rules in this except that you can move stuff around all you want, move parentheses, move the order. So the first one, we've got 3x plus 4y in parentheses. 3x plus 4y, whoops, I'm off the string, sorry about that. Okay, so 3x plus 4y in parentheses plus 10. Okay. 3x plus 4y in parentheses plus 10. And we want to use both the commutative and associative properties. So commutative, again, that's the one where you can switch the order, and associative, you can switch the parentheses. So there are a bunch of different options for this one. So can somebody give me one option that would be different? Is it Stacy? Go ahead. Good. Anybody have another one that they would like to volunteer? Is it Courtney?
Parentheses 10 plus 4y.
Okay. Good. Plus 3x. Okay. Anyone else have another one they'd like to volunteer? Cole?
4y parentheses 3x plus 10.
3x plus 10. Good. So you're just literally moving things around. Then a bunch of different options here. Questions on this? Okay. All right. Am I good to move this, or are you guys still working on this? Okay. All right, so here we go. Let's do today's set of notes is a little longer. In the very beginning, there's a lot of really short stuff to review, but there's a lot of it, so that's the deal with that. Oops, sorry. You guys need that still? All right, here we go. Write an equivalent expression. Use the ratio given for 1. But you guys can see the level of difficulty of the homework tonight. It's not too bad, right? All right, so write an equivalent expression. Use the ratio given for 1. Okay, so that's the number 1, not an I or an L or something. All right, so we have, that's a huge number. Let's do 12x over, 7y, and they give us 8 over 8 for, the number 1. And they want us to write an equivalent expression. So an expression that's equivalent to 12x over 7y. Okay, so does anyone have any ideas about how we might approach this problem? Hannah, right? Good. Perfect. So what she said is we can take the 8 over 8 and multiply it by that fraction to get an equivalent expression. Very good. Okay, so 12x times 8, if we just literally multiply straight across, 12x times 8 is what? 96x. And 7y times 8 is 56y. So typically what we do is we will get expressions like this, the larger ones, and we want to reduce them. The whole point of this is just to see that if you multiply everything by numbers, you'll end up with something that's equal. Okay, but it's the whole thing of reducing. Okay, all right, so let's go the other way. And again, this is the way that you're going to see it more typically. Write an equivalent expression by simplifying. Okay, so 8x over 8y. So what does simplifying mean exactly? Can anybody tell me what, if they were going to define simplification, how would you define it? Juliana?
Just making it smaller, more simple.
Good. So making it smaller, more simple. Very good. Okay, so how could we go about simplifying 8x over 8y? Courtney?
You divide it by itself, divide by 8, and it just goes to
Good. So you're looking for any numbers that both the 8 on the numerator and denominator can be divided by. It happens to be the same number in this case. So if we divide everything by 8, what do we end up with, Courtney?
1x over 1.
Good. 1x over 1y. So now we don't need to write a 1 in front of it to know that there's only one of them. Okay, so just like if I have one shoe, I don't need a 1 in front of it to know that I only have one shoe. Same thing with the x's and the y's, okay? Don't put 1 in front of them. Okay, how about the next one? 6 times, in parentheses, a plus 3 over 24 times, in parentheses, a plus 3. So 6 times a plus 3 over 24 times a plus 3. Okay, so there are multiple things going on here. Let me go back one step really quick. A lot of us may have looked at this and gone, well, we have an 8 on the top and an 8 on the bottom, and we can just cancel them out and we end up with the same thing. That's true as long as you have multiplication. In other words, 8 times x, 8 times y on the bottom. That's how you can cancel them out. If it's being added, you cannot. Okay? Does anybody see anything in this one that's identical on the top and on the bottom? So everybody look at this. It's 6 times on the top, a plus 3. On the bottom, it's 24 times a plus 3. So does anyone see anything that's identical on the top and the bottom? Here. Hold. A plus 3 and a plus 3. So this is an example of, because it's the exact same thing in the parentheses, we can cancel those out. Okay, and we're left with 6 over 24. Now, some of you might be sitting there going, but wait, you just said if there's adding, you can't do that. You can do it if it's the exact same thing that's being added. If it was a plus 3 on the top and a minus 3 on the bottom, you couldn't. But it's the exact same thing. Zarius. You could, but we're typically going to be, we're going to try to get it in this form. This is factored form, and we use factoring to reduce or simplify. Okay, how about 6 and 24? Is there a number that goes into both 6 and 24 that we can reduce this by? 6. Okay, good. So I'm going to divide both the top and the bottom by 6. What am I left with on the top? 1, and on the bottom? 4. So both 6 times a plus 3 over 24 times a plus 3 and 1 over 4 are the same thing. It's been reduced. All right, how are we doing on questions? Okay. Oh, how many people like word problems? hold on a minute. That's where we're going next. Oh. Ooh. That'll be interesting to see how that comes out in the video. If it just blacks out like that. Okay, so here we go. All right, so now we want to write as an algebraic expression. So I will tell you that in the very beginning of Algebra 2, the notes are long. But then they taper off and we get more time to work in class. In the beginning, not so much. Okay, so write as an algebraic expression 5 more than the absolute value of a number. So 5 more than the absolute value of a number. All right, so 5 more than the absolute value of a number. Can somebody tell me how they think? We want to get this into like an actual, something that looks like math as opposed to words. Anyone have any ideas? Is it Stacy? Sorry, say it again. Okay, 5 plus k. Good, that's a good start. Excellent. Now, where does the absolute value piece fit in? Because it says 5 more than. So this is the 5, this is the more than, the absolute value of a number. So we have to change something in here just a little bit. And do we have to use the letter K, or can we use any letter? Any letter. Okay, so what do I have to do here to change this to make it fit that? We're just missing one piece. Hannah? Good. Right. Where do I put those? So she's saying these. That's the absolute value. Oh, we're good. Around the K. Perfect. Just like that. Okay, so those vertical bars are the absolute value symbol. Okay. All right. How are we doing on questions? Yes?
Wouldn't that mean that K is no negative K?
No, not necessarily. Actually,
Oh,
the...
wait, no, K is K and negative K is K.
Yes, correct. Right. All right. Questions? Still good? Can I move it? Okay. So we're almost done. Sort of. Okay, so here we go. Multiply. All right, so we have 4 times, in parentheses, x minus y plus 3z. So 4 times, in parentheses, x minus y plus 3z. Whoop. Ooh, sorry, guys. 3z. Let me go back here. Look at the one on the left. The one on the right's kind of messed up. Okay, so 4 times x minus y plus 3z. All I want to do is multiply here. Raise your hand if you have any idea how to multiply this out. Everybody take a look at it. So this is just getting practice with the distributive property. We think back to the distributive property. Raise your hand if you have some idea about how to multiply that out. Everybody take a look at it. Okay. Keep your hand raised if you would like to volunteer how to multiply this out. Okay. Let's see. Rebel, go ahead.
It'd be 4x minus 4y plus 12z.
Good. So you're literally taking that 4 and multiplying it by everything in the parentheses. Perfect. Okay, let's do another one of those. Okay. 3 times a plus 5b. So 3 times a plus 5b. Sorry about that. Okay, so everybody take a look at that. Raise your hand if you have some idea about how to multiply that. It's same exact thing as the last problem, just different numbers. So, sorry again, that's kind of messed up on the right. 3 times, in parentheses, a plus 5b. Raise your hand when you have an idea about what that multiplies out to. Okay, keep it raised if you'd like to volunteer what your answer is. Okay, is it Zoe?
Yeah.
Go ahead.
So it'd be 3a plus 15b.
Perfect. How many people got the same thing as Zoe? Excellent. Okay, Let's keep going. Next, we're going backwards. We're factoring. Okay, so 7x minus 21. We want to factor that. Okay, factor, that's a fancy word for divide. So when we say divide, we're looking at each of the terms that we have here. So we're looking at 7x and at 21, and we're looking for anything that both numbers can be divided by. So, everybody think about 7 and 21. Is there a number that both of those can be divided by evenly? Okay, keep your hand raised if you'd like to volunteer what that is. Is it Julia? Go ahead. 7. Okay, so 7, that comes out of the parentheses, and what we're doing is we're taking each of these terms and dividing by 7. Okay, so we get 7x divided by 7 is what? X. 21 divided by 7 is 3. Okay, so it's like your reverse distributive property on that problem. Okay? Questions on that? That's a huge one. We're going to be doing a lot of factoring in here. Lot of factoring. Yeah?
I just got x minus 3.
Okay, that's good. That's what's left in the parentheses, but you want to make sure that you keep whatever you divided out in there still. Good. Okay, other questions? Okay, 3x plus 6y minus 3. So 3x plus 6y minus 3. All right. Is there a number that all of these are evenly divisible by? Everybody look at the 3, the 6, and the 3. Rebel? Okay, good. So if we divide the 3 out, we take each of these terms divided by 3, what do we get? Okay, what's 3 divided by 1? Good, perfect. All right, questions on this? Okay. All right, check this out. This is super easy. Collect like terms. How many people feel kind of bored because this is such an easy review? Anybody? Okay. Okay, 4a plus 5a. If you have 4 a's and you add 5 a's to 4 a's, how many a's do you have? 9 a's. Good. Okay, how about 15x minus x? Notice how it doesn't say minus 1x. There's not a 1 in front of it. If you have 15 x's and you take 1 away from those 15, how many do you have left? 14. 14x. All right, last one of these, and then we are very close to being done. 4x minus 7 plus 18x plus 12. Whoop, sorry about that. 4x minus 7 plus 18x plus 12. All right, so we are combining like terms here. So if we start with the x's, are there any other x's over here that can be combined with the 4x? 18x. So you always want to circle, if you're doing this whole like circling thing, make sure you circle whatever the property is in front of it. So make sure the plus gets in there. So 4x plus 18x is how many x's? 22x. Whoops, 22x. Okay, and then we want to do the same thing with any other types of numbers. So we have a negative 7 and we have a positive 12. Negative 7 plus 12, what does that come out to? Positive 5. So we have 22x plus 5. All right, how are we doing on questions? Okay, last type of example and then we are done. Okay, so let's see. All we are doing here is simplifying. So we'll just do a few of these, okay? All right, so we have negative 4b. Anybody remember what a negative times a negative is? So what does this come out to? Just for positive 4b. Good. Okay, how about negative in parentheses x minus p? So what is the property that we're trying to use in this one to simplify this? Good, distributive property. So we're distributing the negative sign to what's in the parentheses. So negative times x is negative x. Negative times negative p is positive p. All right, let's see. We've got 2 more. So we've got 8y minus 4 times 5y minus 6. Okay, so 8y minus 4 times 5y minus 6. Okay, so be careful on problems like this because we're going to get into FOIL later on. If you think back to Algebra 1 FOIL or the box, this is not a FOIL or the box problem. This is another distributive property problem. Okay, if there were parentheses around this first one, then it would be a FOIL or box problem, but there's only parentheses around this, so you're just distributing that 4. Okay, so we have that 8y stays the same. Make sure you include the negative when you multiply. So negative 4 times 5y is negative 20y, and negative 4 times negative 6 is positive 24. Okay, and then if you go back and look, are there any like terms that we can combine? Rebel? 8y and negative 20y comes out to how many? Negative 12y. Good. All right, questions on this? How many people are ready to stop? Okay. I'll raise my hand too. Okay, here we go. So your homework tonight, let me go ahead and write your homework here. Oops, sorry about that. So your homework number 1 is up here. We've got page 18, numbers 3 to 51, 3n. What that means is every third problem. So 3, 6, 9, 12, and so on. And then page 24, numbers 4 through 72, 4n. So that's every fourth problem, 4, 8, 12, 16, and so on. And then 84, 85, 88, and 89. Okay, so what you'll find is that a lot of the problems go really fast. Like problems shouldn't take you any more than like 30 seconds, most of them. There are going to be a couple that take a little bit longer, but questions? Okay, you guys have a couple minutes left.